Hello, I'm Mr. McBrien. This is TEJ3E, Converting Units. So in circuits, we have to deal with a wide range of values for given units. For example, Niagara Falls generates 4900,000,000 watts. And in contrast, an LED in a circuit like the ones we'll build will consume about 0.180 watts. So we have large numbers and we have small numbers. And it would be more clear and more convenient if we could convert these numbers to something that was somewhere between 1 and about 1,000. And today that's what we're going to talk about. We're going to talk about a way to make sure that the numbers to which we refer are between 1 and 1,000. Now you might argue, couldn't we just say million or billion in front of these units? And the answer is, of course, yes. But we'd have to come up with some kind of symbol because we can't write words like that on things like the output from multimeters. And it's not very concise. But maybe, just importantly, engineers and scientists like to make themselves sound smart, so they can't use something that the average person can easily understand. So instead of saying that Barry's 114,000 meters away, we decide we want to say it's 114 kilometers away. So how do we do these kinds of conversions and do them successfully? Well, it's really pretty straightforward. To convert large numbers, we'll use prefixes like kilo for thousand, mega for million, giga for billion, and tera for thousand billion, or some people call it trillion. And so if we want to convert from meters to kilometers, we'll divide by 1,000. If we want to convert small numbers, then we use prefixes like milli for thousandth, micro for millionth, nano for billionth, and pico for trillionth. And so to convert meters to millimeters, we would multiply by 1,000. And as a basic overview, we have this table that is also reproduced on your worksheet. So these are the prefixes we'll need quite often in our course. For the large numbers, like I said, we have kilo, mega, giga, and tera. And for the small numbers, we have milli, micro, nano, and pico. And if we want to make conversions between these things, it's really pretty simple. If we want to go, for example, from meters to terameters, we need to divide by a 1 with 2, 3, 6, 12 zeros. If we want to go from meters to picometers, we would divide by this number, 0.000000001. In contrast, if we want to go from, say, picometers to meters, we would multiply by this number. Okay, and if we want to go from, say, megameters to meters, we would multiply by 1,000,000. All right, so let's see how we use this kind of idea in anger. So let's go back to our statement. Niagara Falls generates 4,900 million watts of energy. Convert to more reasonable units. So we need to make the number smaller. So we go to the higher part of the table and we find a similar number of zeros that we have here. So with 9 zeros we have giga. And then what we can do is simply divide by that number, 1 billion watts per gigawatt. Divide by that number, and we find that Niagara Falls generates 4.9 gigawatts of energy. Small numbers, very similar concept. So if our circuit consumes 0.81 watts of energy and we want to convert it to more reasonable units, something between 1 and 1,000, we go back to our table and we look for something that's going to move our decimal 3 places. We need to move it 1, 2, 3 places, and that'll give us a reasonable number. And so we look and we say, okay, let's convert watts to milliwatts, and that'll mean that we'll be dividing by 0.001 or multiplying by 1,000. So we divide by 0.01 watts per milliwatt, and when we punch this into our calculator, dividing 0.81 by 0.001, we get 181 milliwatts. Okay, and it is very common for students to have trouble with unit conversion, not with the concept, which is really pretty easy to understand, but with knowing when to divide and when to multiply. And what you can do is you can memorize this idea of when you move from unit to a prefix, you memorize what you have to do. But there are in fact 2 ways that you can guarantee that you get the direction right every single time, with varying degrees of certainty. So let's talk about unit analysis first. If you're good with algebra, you should be using unit analysis pretty much every time you apply an equation. And the reason why is because it will help you to solve these problems with great certainty and to understand the mathematics of problems better. But it's also very powerful when it comes to unit conversions and with regards to making sure we go in the correct direction. So let's consider the prefix kilo or 1,000. We can rewrite that line in our table as 1,000 meters per 1 kilometer, or remember that the division line, we can consider this division to be the same as saying per. So 1,000 meters divided by 1 kilometer. And as long as we treat this way, we can start to write our unit expression as if it's a fraction in its own right, and we can cancel our units algebraically to make sure we come up with what we want. Okay, so let's apply that concept. Let's say a mod is 0.0019 kilometers tall. Well, this isn't a very expressive way for us to look at that measurement. It would be more appropriate for us to choose different units. So what we can do is we can say, okay, instead of using kilometers, we should be using meters. And then we know that we use that idea of 1,000 meters per kilometer. And we multiply it out, and you can see that kilometers is on the bottom and on the top. So we can cancel these 2 out. 1 on the top, 1 on the bottom. They cancel out and leave us with just meters. And so we're canceling the units the same way we might cancel mathematical numbers. We can cancel them algebraically. And we get the answer of 1.9 meters. Kilometers canceled, leaving us with meters as our units. And hey, this looks pretty good, right? Well, let's imagine what happens if we make a mistake. Let's imagine we weren't quite sure what we were doing and we decided to divide instead of multiplying. And so we're still using the same conversion. We're trying to go from kilometers to meters because we know we should. But we decided to divide instead of multiplying. Well, the problem with this, of course, is we're going to get the wrong answer. But if we do the unit analysis, if we take and do our unit analysis, we can try to cancel. And notice what happens. Instead of getting meters as our answer, when we divide by meters per kilometer, kilometers goes up to the top, and we multiply kilometers times kilometers. Meters moves to the bottom, and it doesn't cancel. And our units become kilometers squared per meter, which isn't meters at all, and isn't a measure of distance, unless we do some canceling. So, this ridiculous answer that we get, not in meters, and not between 1 and 1,000, isn't a good unit of height that we expected to see, and we know something's wrong, and we can go back and put a multiplication symbol in there. Similarly, if we'd multiplied by 1 kilometer per 1,000 meters, which could have been perfectly reasonable, if we multiplied that, we would have also gotten the wrong units and the wrong answer. So unit analysis can point out to us when we're using the wrong expression. However, the third question is another way of looking at this problem. Every time you write down the answer to a given problem, you should ask yourself the 3 questions. What are the 3 questions? Are my significant figures correct? And you probably haven't studied this yet, and we'll worry about this later, both in grades 11, 12, and in university. We need to ask ourselves, did I include my units, and are they correct? Because numbers have no meaning without units. And the third thing we need to ask ourselves before we put an answer down is, does my answer make sense? And it's this third question that we can use to our advantage today. And the reason why is because the third question can often detect when we divided when we should have multiplied, or multiplied when we should have divided. So the same mistake, we can look at it from a different perspective. Ahmad is 0.0019 kilometers tall. Convert to more reasonable units. And this time we're not secure in our unit analysis, so we're not going to try that. And we divide instead of multiplying again. But this time we're not examining the units, because we have a pretty good idea of what kind of answer we should get. We know Ahmad is going to be roughly 2 meters tall, and we can always make those kind of estimates. So when we make this mistake and divide instead of multiplying, we get this ridiculous answer of 0.00000019 meters tall. And this answer clearly is not correct if we're watching carefully. And we can look at this and we can say, hey, maybe we should have multiplied instead of dividing. So, I'd encourage you to always look at the evidence you have available to you when solving a problem, and make an estimate of what your number should be approximately. And if you don't see something like what you expect, go ahead and re-examine the problem. Okay, to summarize, when we have a wide range of values for variables, we can be forced to write a lot of zeros, either before or after the decimal point. Unit conversions allow us to use prefixes to stand in for zeros, to represent groups of 3 zeros in particular, and make numbers more manageable. So we can convert between units by multiplying and dividing by thousands, millions, and billions. And if we're tricky, we can make sure we're using the right approach, division or multiplication, by applying unit analysis and the third question. Okay, so go ahead and work on your homework worksheet, please. Have a look. The answer key is up on Google Classroom. Have a look and bring any problems you have to class tomorrow. Thanks very much and have a good day.